So let's start. How many of you have ever built an ML pipeline before? Quite a few, good. How many of you have used Parquet before? Oh, excellent. And how many of you have used PyArrow before? A little. Okay. So this talk, like the title says, I'm talking about Parquet and PyArrow to build an example ML pipeline. And I'm going to focus on this question mark in the middle. So how we build a storage system to support a typical diverse workflow that we use in an ML pipeline. But I want to start from the end goal, why we do all this. Because at the end of the day, we want to provide some value to a customer. There can be an internal customer for, or an external final client. So we want to integrate data from different sources and provide some insight. And this will be in the form of dashboards, in the form of reports, in the form of custom apps. But we need to integrate typically data from different sources. So since we need to integrate many sources, our storage system needs to support these different workflows. The first one is collecting the data from the operational source. What is the operational source? Is the ground truth of the data. For example, the transactions of your bank, it's an operational source, the list of transactions. Or the user behavior, the user session, you track all the behavior of your users and you generate some data. And this data is generated in real time. So you want a storage system that stores this data in real time. So that's the right pattern, the pattern number one I'm talking about. Then we have different read pattern. First of all, we're talking about machine learning. We need to do training. To do training on a data set, we need to do a full scan. We read the whole data set from start to the end and train our model. And it needs to be really efficient because typically we train the model several times and the data set can be huge. So this is the first read pattern we need to support. Then once we have the trained model, we need to do inference on fresh data. So we need to be able to read the mini batch of data that is coming at that point in time and do model.fit, predict on that data. And the last pattern I'm talking about is so-called the analytics query pattern, because no result can be presented without a context, usually. So typically, you need to add to your model result also some information that you get querying the full data set with a large historical depth, but selecting some columns and selecting only some rows. So these are all the pattern we are going to use. Okay, so let's start from the table layout. We have on the left side a typical table. I put images in it, but it's just a normal table. And usually you can store a table in memory or on a disk. You need to store it on a linear buffer, right? So you have two layouts: row-oriented layout, in which you put one row after the other. So you have dog, girl, man, dog, girl, man, man. Or in a column-oriented, in which you put first column, second column, third column. Which one do you think is most useful for this use case? Yeah, it's in bold, so column one. Why the columnar layout do you think is better? Who knows? So you talk about it's more efficient to do operation because we vectorize. So that's one. What? Right. So if you have many time series, maybe you want to just pick one and skip the others. So if you have a column layout, you can skip all the others. So you reduce I/O. It can be I/O to the disk or I/O to the network. And third, right. So if you put all the same type of data together, all the dogs together, all the girls together, all the men together, what you gain? You can do compression better. So that's are the 3 points. You reduce I/O because you can skip parts that you don't need. You reduce storage size because you compress better, because all the same kind of data is together. And you save time in computation because you vectorize. So what's the columnar format we are going to use? Apache Parquet. This is an open source format. It's an open standard. It has a huge community. It has no vendor lock-in. It is very efficient, compressed, binary, self-describing, and so we're going to use Parquet that is well supported in Python as well. This is a little bit of details about the internals, but I will tell you only 2 things. Don't get confused about the complex slide. I will tell you only 2 things about the file format. One, it is divided in row groups. Inside each row group, there are column chunks. There is column chunk A, column chunk B, and column chunk 3, Z. And this is the columnar nature of the format. So all each column stays together and separate from the other. The second thing that I'm going to say is this metadata, the red boxes that you have there. So you have statistics about the columns, mean, max, and count, and these allow you to skip column chunks that you don't need a query time. So if you know that you're querying value 3, and you know that you're querying value 3, but in your column you have only 5 to 10, you can skip that chunk altogether inside the file. So you can read only the chunks that you need. And the other cool thing about Parquet is that you can build a larger data set by using a folder structure. So you can have a folder year. Inside a folder year, you put a folder month. And then inside a folder month, you put many Parquet files. Then when you read the data set, you point to the root folder, and you see the data set as an entire old data set, and you can query it. And what happens is that if you query it and ask only for month 2, the engine is going to read only that folder and skip all the rest, and will be efficient. It's called the partition pruning. Okay, tuning, I'm going to say just that single files needs to be around 100 megabytes as a rule of thumb. And if you are going to get millions of Parquet files in a data set, it's not working well, so you need to partition more. Okay, the second project is Apache Arrow. Apache Arrow is what we are going to use to read these Parquet data sets. But Apache Arrow is more than that. Not only reads the Parquet datasets, but is a cross-language development platform for in-memory analytics. So that's taken from their website. Basically, it's a format for in-memory representation of a table. Parquet is a on-storage representation, and Arrow is an in-memory representation. And it's on top of that is also a protocol for serialization, deserialization, and sending data between nodes, and is well supported across many languages, including Python. And what you can do with Apache Arrow is share data between processes with 0 copy. You can have a Python application that has a 10 gigabytes table in memory and give it to a Java application without copying it. The Java application can access the same buffer. You don't need to duplicate. And this kind of inefficiency when you communicate between processes, it's one of the biggest bottlenecks in analytics. And Arrow solves that. On top of that, is automatically parallelized with multi-threading and supports also remote procedure calls. So you can call you can send this data with low overhead to different nodes. Okay, we are going to use PyArrow, that is a Python library that binds to the C++ implementation of Arrow. And in particular, the dataset API. That is a subset of the API, kind of newer version of the API. And the nice thing about it is that you can read any format, Parquet, CSV, ORC, and you use the same API. You can use it, and it's quite convenient. Okay, so let's go back to the workflows. First workflow, we need to save our operational source data into our storage system. So we get data in small batches in this case. So what we do, we load the data. Let's say that we receive the data already in a Parquet file, then we load it with a PyArrow as a table, calling dataset, and the method toTable. In this case, with toTable, we materialize the table in memory. We load it. So you need to be careful that the data cannot be too big. If you get the data from another source, for example, a database, you have another function call, but you end up with a table in memory anyway. For SQL, for a relational database, you most probably cannot use PyArrow, but then you can always convert it to a PyArrow table. Then you typically transform this table with any arbitrary transformation. So here is a function that takes a table and returns a table. And in this example, I just had the year and month column. Don't try to read it all because I put all this code on GitHub and there are fully runnable examples. So I'm just showing really quickly some snippets of code, but you can play with it at home. Okay, we create the year month column so we can save this file on disk. And we save it with this write dataset function. That is the universal function of the PyArrow dataset API. Since we use this function to save not only a single file, but also entire dataset, we are going to break down this line by line. So first is the data we want to save. In this case, this is a table, but you can also pass an iterator. If you pass an iterator that return batches of data, this single function call will consume the iterator and save an entire dataset for you, and it can be much larger than RAM. Then you have the location where you can save it, both local and in cloud. You have format options that you can pass to configure the internal format of Parquet. You have the partitioning. This is important. You specify here that you want a partition year and a partition month. So 2 levels of folders when you create your dataset. This is a Hive partitioning is just name of the column equals value. These 2 columns, year and month, are not saved inside the Parquet, but they will show up once you read the dataset back. They will materialize for you. The PyArrow will do it for you. Then you have write option. You can choose to append or overwrite files in the same partition. In this case, we want to append a new file every time a new mini batch arrives. Then we choose the file name. And usually we use this trick of UID to generate random file names. We have a callback. So when we save a large data set, we can monitor each file. We can call the callback every time the file, the callback is being called every time a new file is saved, so you can monitor the progress. Okay, so once you save the data from the operational source in this way, you end up with the dataset on the left. Each partition can have a lot of Parquet files. It can have thousands of Parquet files. Do you think it's efficient or not? Yeah, right. But in this example, this is operational data arriving in real time, so it's probably a small file. What we want to usually do is compaction. So compact this data set, this file in a single Parquet. And if these are 100 megabytes files each, you don't want to create a 1 terabyte Parquet file. So you better rethink your partitioning scheme and have more granular partitioning so that the size of each individual file stays within a reasonable limit. How we do partitioning, compaction in PyArrow. This is an example. We load the dataset with the S dataset as before. We don't convert it to table, but we create a scanner object that is just an iterator. And then we save it like before we write dataset. Instead of passing the table, we pass the iterator, the scanner. With this single function call, we can have a 10 terabyte dataset, and PyArrow will work through it and save it in a compacted format. And your input source can be on cloud, and your output can be on cloud as well, like S3 storage. Okay, so we end up with basically three versions of the dataset. The raw data that is saved by the operational source, the ingested one that is partitioned but with a high granularity, and that compacted version. The ingested one is good for retrieving a single file quickly because we already have the same granularity of the operational data. So if we need to pick one, we just pick that file that we need. And the compacted version is good for ML training or for analytical queries. And we are going to see this workflow. To do like a full scan for ML training, we open the dataset and we use dataset.toBatches to iterate through batches. So PyArrow will create batches for you and give you one batch in time. And you can use these batches to do your model training. You can do it on a single host, or you can do distributed training. You can do it as you wish, as you need. The second read pattern is the inference workflow, in which you pick a single file. So as long as you know the name of the file, the full path on the cloud, you can open that file with the s.dataset. You pass the path and the file system. File system can be local file system or a cloud provider. It can be cloud, Google storage, it can be Amazon S3, Azure, Blob storage, whatever. And in this case, you converted two tables and, for example, two pandas directly, and use it for model.predict and perform your inference. And finally, there is the analytic query workflow, in which you want to select a subset of columns. You don't want to read all of them. And you have a set of filters. Let's say that you want a specific year, a specific month, and a range of days, only the first 5 days. Here is the first 4 months of the 2020, the first 4 days of each month, and only rows where the column called like that, cat called 0 as value foo. And then you call dataset to table, like before. You transform the dataset into a materialized table, but passing the columns that you want and the filters that you want. And what happens is that PyArrow looks at the filter, and since the dataset is partitioned, it's going to do first partition pruning. So it's going in the subfolder corresponding to year, month that you selected, and read only those folder and skip all the rest. Then it goes on the Parquet file inside that folder and does filter push down. So it applies the other conditions. Since we have statistics for each column, it can figure out whether a particular row group has the day 5 or not, and skip completely all the row groups that are not day less than 5. And the same for the categorical variable that needs to be foo in this case. On top of that, we skip also all the columns that we don't want. So we only read the columns, the 3 columns that we specify here. So this query is extremely efficient. We are going to only read the data that we need and bring it in memory. Okay, how we scale this workflow as the dataset becomes bigger. You can use a single host, your laptop or a virtual machine, and you can make it bigger. If you have more CPUs, PyArrow is going to parallelize proportionally to the number of CPUs, so it will become faster. But you can increase this vertical scaling up to a point. So at some point, you need to do horizontal scaling, so having multiple jobs that do this processing for you. And how you multiple jobs? You need a way to distribute the work, like with a queue. So, for example, this is an example architecture. If you keep track of all the files that you have in a queue, then you can allocate multiple jobs, either on a Lambda function or jobs on a Kubernetes cluster, and each job is going to read the message, the file name, and then pick that file name and process it. And you can orchestrate these in parallel. Okay, the last thing that I want to mention is a few projects in the ecosystem. First, these are other tabular format based on Parquet, Delta Lake and Iceberg. They add 2 important features. First, ACID transactions like relational DB and versioning. And these are very important for many use cases. Iceberg in particular has also more advanced features that allow you to select, when you apply filters, you don't have to specify specific partitions, but you can specify a date range, and you don't have to specify the name of the partition. It's called partition hiding. So I don't have time to explain in details, but it's really cool features that makes your code more maintainable. And other 2 projects I want to mention are in the Arrow Rust ecosystem. There is a growing Rust community, and 2 tools coming out of this community is Data Fusion, that is a query engine executor, and Ballista, that is a query distribution system that uses Data Fusion. And from Python, we can call these tools because this is native code, and we can always easily access native code. Okay, that's it. So who's going to use Parquet and PyArrow in the next project? Good. Okay, take home message. Parquet and PyArrow is really efficient, works both on cloud and local storage. It scales from small to big workloads, and it's all based on open source and community-driven projects. Thank you for your attention. And here you're going to find all the runnable code to play it at home. You can generate some toy dataset with the scripts in this repo and play with it, querying it, transform it.
All right, that was a great talk right there. And now we have like 4 minutes for some questions. Even if you don't have questions, go to slide on upvote the questions that you think should be asked first. Else I will just go first in, first out. Why would you partition on year, month, day separately versus an ANSI date string format such as year, month, date? Yeah.
Sorry.
It's okay.
Okay, so the question is, why do I partition separately by year, month, and day, 3 layers of nesting, instead of just using 1 string? In the example, I create 3 columns, but then I use 2. So maybe you want to leave out day for a particular data set, You can decide to add one level later on. If you use a single string, it's like recreating all the partitions from scratch. It's an option, you can do it. What is going to happen when you load the dataset is that you have a single string with all the date. And then maybe you can convert it to the datetime object, but only date in that case, because you have the date. You already have a datetime column, so it's a kind of duplication. I think it's more modular, so you can compose and change only, add additional partitioning. Let's say that you start with year and month, and then you add day without changing the first part. And when you query, if you query by year and month, you don't need to change that part of the query because they are already there. Instead, if you change completely the string, then you need to change the logic of the query.
All right, now top one question is, where's the difference between using pandas, read Parquet function, and reading Parquet files with PyArrow, and convert the data to pandas data frame?
Okay, great question. When you use pandas read Parquet, pandas uses PyArrow by default to load the dataset and loads it in memory. So you can load as much data as you can fit in memory, usually. But unfortunately, you need also to convert the data. So you first start from the Parquet, PyArrow converts it in Arrow format in memory, and then pandas converts it from Arrow format to his internal format. That in some occasion you can save some copy, but in most cases you do a complete memory copy for this second translation, and is less efficient. So if you need the power of pandas, because you need to do some transformation that you can only do in pandas, then do it. But for many workflows, you can transform and compute directly in Arrow. Arrow provides compute function, so you can avoid using pandas, and the round trip will be more efficient.
All right. We have 30 seconds, so it's what are the pros of using PyArrow instead of pandas?
Yeah, it's basically the same. You avoid the overhead of converting to pandas and then back to Arrow if you are going to store always in Parquet anyway.
All right, we don't have any more time for questions, but I guess you can always just tackle him when you see him outside and ask him anything about PyArrow. Now I just want to thank you so much for this presentation.
Thank you.